Okay, now the derivative of inverse trigonometric functions is possible if we know implicit differentiation. So let me remind you, inverse trigonometric functions are all the functions that look like arcsin of x, arc cosine, arctangent, and we can have arc cosecant, arc secant, and arc cotangent as well. The notation, you can see the word arc in front of the functions, or you can say the inverse of sine, inverse of cosine, the inverse of tangent, and just remember that this is not reciprocal. This just means inverse. Okay, so because it's an inverse, you know that the sine of y is x. Remember that we start with the function y equals sine of x, and for us to be able to find the inverse, we switch x and y, and then we solve for y. But in this case, I'm not going to solve for y, I'm just going to leave it like that, because we know implicit differentiation, this will not be a problem. So I'm going to take the derivative respect to x on this side, and the derivative of the right side respect to x. So when I do that, derivative of sine is cosine, evaluated at the inner function, times the derivative of the second function. Derivative of y would be 1 times the derivative of y respect to x, which is y prime. And that equals simply 1. So I have y prime equals 1 over cosine of y. So the derivative of the arcsine function is 1 over cosine of y. But really this doesn't solve our problem, because we don't know that function, the function y based on x. So we need to go a little further. Now the other thing we're going to use is the fact that sine square of theta plus cosine square of theta is 1. And it doesn't matter what variable I use here. I could say sine square of x plus cosine square of x equals 1, or sine square of, I don't know, anything, star, cloud. As long as I'm using the same function, then this always equals 1. So I know that sine square of y plus cosine square of y equals 1 as well. So I'm going to use this fact, and I know that cosine of y, solving for cosine of y, it will be 1 minus sine square of y. So I know that sine of y is x, so replacing this is 1 minus x squared. So when I replace that here, I know y prime is 1 over 1 minus x squared. And I found the derivative of arcsine. So derivative of arcsine of x respect to x is 1 over square root of 1 minus x squared. In your book, it's showing you the notation with a -1, which is still the same. Derivative of the inverse of sine respect to x is still the same thing. Now we're gonna do the same procedure to determine what's the derivative of arctangent. So I'm gonna do pretty much the same. I know that the function y equals tangent of x has an inverse function arctangent, and I swap x and y, so I have x equals tangent of y, and then I'm trying to find the derivative of this function. So I'm going to take the derivative of x respect to x equals derivative of tangent of y respect to x. I'm going to use the Leibniz notation in this case so that you see that it's the same idea. Derivative of x is 1, and derivative of tangent of y respect to x, I notice that this is a function inside a function, so I have to apply function rule. Derivative of tangent is secant square of the inner function times the derivative of the inner function. which is dy over dx. So now I'm going to solve for dy over dx. I'm going to just leave it on one side of the equation, so this will be 1 over secant square of y. So this is really not very helpful, so I'm going to use the equivalence. Another Pythagorean identity, 1 plus tangent square of y is secant square of y. So secant square of y is the same as 1 plus tangent square, so I'm just going to replace it here. There's no need to solve. And then I know that tangent of y is x, therefore tangent square of y is x squared. So the derivative of arctangent of x respect to x, I figure it out, and it's 1 over 1 plus x squared. So these are the kind of formulas that you need to remember. You're not going to be asked how you're coming up with them. However, this is a good exercise. It's touching a little bit of our Pythagorean identities that we should know. And it's also showing you how to simplify stuff. So very useful. The other derivatives, you can see them in the book. Memorize the formulas because it's expected that you know them. Okay, so in example 5, we're going to use what we just found out. I'm taking the derivative of this function, and I notice that is the reciprocal of arcsin of x, or the reciprocal of the inverse of sine. So let me just write it as a power, so that I can apply the power rule rather than the quotient rule, because that's more troublesome. So I'm going to rewrite that as taking the derivative respect to x of a function that looks like this: inverse of sine, reciprocal. Okay. So now I'm just using the power rule. This will be the new coefficient, and the new exponent will be 1 less than that, which is -2, times the derivative of the inside. What is the derivative of arcsin of x? You just learned that 1 over square root of 1 minus x squared. So now putting it all together, I'm going to have a -1 on the numerator, and then the denominator will be arcsin of x squared times the square root of 1 minus x squared. And there is nothing to simplify in here. This is the derivative, or y prime, or df over dx. And that's all. Now for part B, they're asking me to find the derivative of this function. I notice that there's a few things going on. It's a product of two functions, and the second function is a composition of a square root and arctangent, so you just have to be careful with that. Applying the rule, I'm gonna call, you can use u and v, or you can use f and g. It doesn't matter what you use. I'm gonna call this my f and this my g, and I'm gonna apply the quotient, the product rule. So it's f prime times g plus f times g prime. Derivative of f would be 1 times g, which is arctangent of the square root of x, plus f, which is x, times the derivative of g. Now this is the one that I have to apply the chain rule. So derivative of arctangent, you've seen that, is 1 over 1 plus x squared. However, you don't have arctangent of x, you have the arctangent of the square root of x. So it will be 1 plus your inner function, the derivative of the outer function evaluated at the inner function, times the derivative of the inner function. This is x to the 1/2, so 1/2 will be the coefficient x, and the exponent is 1 less than that, which is -1/2. So you're done. You just have to rearrange this. This will be, let me just make a line here, arctangent of the square root of x plus I notice that I have x times x to the negative 1/2. The exponent here is 1, so 1 plus negative 1/2 is 1/2. So this will be x to the 1/2 or square root of x. Either way, it's fine. Over, what do I have in the denominator? I have a 2 multiplying this expression. Now show me that you know what is the square root of x squared. And then that will be f prime of x.